Hello guys, you're welcome to this video. Basically, in this video, we are going to be looking at how to balance redox reactions. And I must tell you, first of all, that redox reactions are reactions which contains an oxidation reaction and a reduction reaction. So it is a two-in-one reaction, oxidation and reduction. So I said we have oxidation reaction and we have reduction reaction. So basically, what does the term oxidation mean? So oxidation implies the addition of oxygen, the loss of electrons, and the removal of hydrogen. While reduction means the removal of oxygen, the gain of electrons, and the addition of hydrogen. So when we talk about redox reactions, we are talking about reactions that are composed of both oxidation and reduction reaction. So quickly, we'll be delving into balancing of redox reactions. I want to let you know that there are two mediums through which we can balance redox reactions. The first medium is called the acidic medium, while the second medium is what we call the basic medium. So basically in this video, I'm going to be explaining the two different mediums through which we can balance redox reactions. Now let us first of all begin with the acidic medium. So we'll be looking at acidic medium. So basically, there are rules through which we must actually follow in order for us to balance reactions in an acidic medium. The first rule is to divide the reaction into two half cell equations. Now, these two half cell equations are the oxidation reaction and the reduction reaction. Secondly, we balance atoms other than oxygen and hydrogen. That is, atoms that are not oxygen and that are not hydrogen. We have to balance them first. Thirdly, we balance oxygen by adding water on the oxygen deficient side of the reaction. That is the side that is lacking oxygen, we add water. The fourth rule or the fourth step is to balance hydrogen by adding hydrogen ion H plus. Remember, I told you that to balance oxygen, you have to add water, H2O, on the side that is lacking water, while the side that is lacking hydrogen in the rule 4, we add H plus. That is actually going to balance the hydrogen on the other side of the reaction. Then the fifth rule is to balance the charges by adding electrons on the electron deficient side of the reaction. Now, these things are things that we must do in the two half cell equations. These are things we must do in the two half cell equations that we divided the reaction into from step 1. Now, the last rule is to multiply the electrons in the half cell equation 1 by the entire of half cell equation 2 and multiply electrons rather in the half cell equation 2 by the entire of equation 1. All right, so if equation 1 has 2 electrons, we use 2 and multiply everything in equation 2. If equation 2 has 3 electrons, we use 3 and multiply everything in equation 1. Why are we doing this? We are doing this so we can have equal electrons, so we can be able to cancel out electrons. Now, the electrons that we are actually supposed to add when we are balancing the charges is represented in the form E minus. This is how we represent electrons that we use in balancing charges. Now, after we must have done that, it's important for us to cancel out recurring species. What do I mean by recurring species? I'm talking about things that are actually appearing more than once on either on the same side of the two half cell equations or on opposite sides of the two half cell equations. So on the same side of the half cell of the two half cell equations, what we have to do is to add. Now, if we have recurring species that is the same species, for instance, there's water here and there's water on the opposite side in another half cell equation, what we have to do is to subtract. And that is the cancelling I'm talking about. At the end, we must ensure that we subtract and add respectively the recurring species that are in that reaction so we can have our balanced reaction. When we are done, we have to check to see if it has been balanced. So quickly, we'll be looking at an example, all right, that will help us to understand balancing redox reactions in acidic medium. So basically, we are going to balance this reaction. MnO4 minus plus I minus to give us MnO2 plus IO3 minus. All right, so this is the reaction we are going to be balancing. All right, and we are having a reaction that is moving from reactant side to product side. And of course, we need to first of all follow the rules. Okay, we must abide by the rules. Now the first rule is to first of all divide this into two half cell equation. I always say this, that the best way to divide this is to actually pick the like terms. All right, the like terms. So basically, what are the like terms? You pick this, they are like. You pick this, they are like. So we have MnO4 minus then MnO2. Then we also have I minus and IO3. Okay, remember that this step is to divide what this reaction into two half cell equations. And remember, I told you that these two half cell equations, one will be oxidation reaction and the other would be reduction reaction. Now let us look at the one that is oxidation and the one that is reduction. I told you what oxidation means. I said that oxidation is the addition of oxygen, while reduction is the removal of oxygen. So let us check this particular first reaction. If you realize here we had four oxygen, here we have two. All right, so what happens is that oxygen reduced from 4 to 2, so this is reduction because oxygen was reduced from 4 to 2. Now here oxygen was added to this to form this, so it means that this is oxidation. All right, so like I said, you have to first of all divide into two half cell equations. So this is step one. Now step two, we have to balance atoms other than oxygen and hydrogen. All right, other than oxygen and hydrogen. If you look at it, the atoms that are neither oxygen nor hydrogen here are manganese and iodine. If you look at this first half cell equation, you realize that manganese is already balanced. So what we have to do is that we'll just repeat it. For the fact that it's already balanced, we'll repeat it. Why this one, iodine is also balanced, one here, one here. So I minus, then IO3. Please ignore the charges that are not balanced. If you look at this, iodine is minus one here. All right. So please, regardless of the fact that it has not been balanced, there is a step that we'll get to where we'll balance the charges. All right. So this is the second step. Now, for the third step, we balance oxygen by adding water. So step three we say balance oxygen by adding H2O to the side that is deficient, that is the side that is lacking oxygen. That's what we have to add oxygen to. We have to add water rather to. Okay, so we add water to the side that is lacking oxygen. All right, so how do we do that? Please, I would encourage you to look at the previous step when you are actually balancing. As we are in step three now, we have to look at step two. If we get to step four, we'll look at step three. That's the order, so you will not make any mistake. All right. So now looking at step two, we have to add water to this side because it is this side that has more. So this side is lacking. If you look at it, oxygen is 4, yeah, oxygen is 2. So we say MnO4 minus. So we have MnO2 plus. So we need to add 2 molecules of water, 2H2O. While on this side, if you look at oxygen is 3 here, there's no oxygen here. So we have I minus plus 3 what? 3H2O to give us IO3 minus. If you look at it now, oxygen is now balanced. All right. The next step now, the next step is to balance hydrogen by adding hydrogen ion. So the next step is to balance H by adding H plus. Don't forget that we are adding to the side that is lacking. Now, if you look at this first reaction, you realize that hydrogen is 4 here. There's no hydrogen here. So it means that we have to add H plus on this side. So this will be 4H plus because hydrogen is 4 here. All right. So this is MnO2 plus 2H2O. All right. Then as for here, this will be I minus plus 3H2O. All right. If you look at it, hydrogen is 6 here. So we need to add 6H plus here. IO3 minus plus 6H plus. All right. As you can see, we have balanced hydrogen on both sides. We have also balanced oxygen. So the next thing we have to do now is to balance the charges. All right. So balance the charges in these two half cell equations. All right. So for the first one, we say MnO4 minus plus 4H plus to give us MnO2 plus 2H2O. Now look at this, guys. This particular substance, this particular ionic substance has a charge of -1. Now why this one has a charge of +4? This plus here is being multiplied by the 4 here. So please note, if there was no coefficient here, this would just be +1. But it's 4 times +1. If there was something like 2 plus here, it would have been +8. So basically, it multiplies, while here is 0 and here is 0. All right? So now if we are to balance the charges, this is -1 plus 4. -1 plus 4 is +3. Okay? While here is 0. Now, looking at this reaction now, -1 plus 4 is +3. Here is 0. Now, the side that is lacking. Now, let's just take for instance that a man lost, let's say, three naira. All right, then another person did not lose, did not gain. 0. In chemistry, plus means loss, while minus means gain. Please take note of that. So now this +3 now means that it has lost 3 electrons. This one 0. So now the idea now is to add electrons. That is E minus. That is our step 4. Add electrons, okay, to balance the charges. That is, I told you, E minus. Okay. So basically, where do we need to add electrons? We need to add electrons here because the guy that did not lose and did not gain is better than the guy that lost. So now the idea now is that what will we add to 0 now to give us or what will we add to +3 rather, because this is what we have to add. What do we have to add to +3 to give us 0? The answer is -3. It's +3 minus 3 that will give us 0. But we will not have to write -3. Rather, we write +3E minus. This 3E minus means -3. Please take note of that. Whenever you see E minus, please take note that it means minus of that coefficient. If it's just E minus is -1, 3 minus is -3. But you're saying plus because you are adding electrons. That's why you're writing plus here. Okay, so it means that this is where you need to what? Add. So you say +3E minus. All right. Now, because this one side has lost 3 electrons, that is why we are adding to balance here. Then now, the next one is the second half cell equation, okay, which is I minus plus 3H2O now to give us IO3 minus plus 6H plus. Now look at this. This is -1, this is 0, this is -1, this is +6. All right, -1 plus 0 is -1, -1 plus 6 is +5. So between here and here, the side that is lacking is +5. -1, it has gained 1, +5, it has lost 5. So in order for you now to balance this, to make sure that this side is -1, this side is this particular side is -1. All right, what will you add to +5 to give you -1? The what you add to +5 to give you -1 is -6. All right, but you will not say -6, rather you say +6E minus. So it means that you say +6E minus. So are you seeing where we are adding it? We are adding it at this point. Remember, the previous one we added here. So we are adding this one here now. All right. So at this point now, we've been able to balance our charges by adding electrons. The next thing now is to ensure that we have similar electrons, equal electrons, okay, for both half cell equations. Here we have 3 electrons, while here we have 6 electrons. Okay, so the idea basically is to see how we can make both of them to be the same. There's a common factor here. All right, there's a common factor here. Okay, for us to make 3 to be like 6, we need to multiply here this entire reaction by 2. Okay, this entire reaction by 2. Why we'll have to multiply this by 1. All right, or even if we multiply this by 6, okay, everything by 6, here will be 18. 3 times 6 will also be what? 18. If we divide 18, okay, by 3, okay, we'll still have 6. All right, we'll still have 6. If we divide 18 by 6, we'll still have 3. All right, so the major idea now is to look for the common factor between 3 and 6. Okay, the common factor between 3 and 6, and that has to be 2. We'll multiply this by 2 and we'll multiply this by 1, so we can have equal. All right, or if to avoid confusion, we just like I stated, multiply this entire reaction by 3 and multiply that entire reaction by 6. All right, that's the idea. So now let us do that. So if we do multiply this, so we'll multiply, if we multiply equation 1 by by 6 and equation 2 by 3. Okay, so it means that we'll have 6MnO4 minus plus 6 times 4 is 24H plus 6 times 3 18E minus, then we have 6MnO2 plus 6 times 2 12H2O. Then if we multiply this by 3, it means that we'll have 3I minus plus 9H2O to give us 3iO3 minus plus 3 times 6, 18H plus 3 times 6, 18E minus. 18E minus will cancel 18E minus. All right, that is the idea, to have equal electrons. All right, then let us check what we can also cancel. We have 9H2O here. We have 9. Remember, I told you that it's only when they are on the same side that you can add. When they are on opposite sides, you have to subtract. All right. So here is 9. If you subtract it from this 12, you'll be left with 3H2O. All right. Because 9 plus 3 will give you 12. Is there any other thing we have to cancel? All right. For 3I, we have 3I here, but they are not on opposite sides. So we cannot cancel anything. Besides, these are not even things that can cancel because they are not the same. All right. So then how about H plus? If 18 enters 24, we'll be we'll be left with 6H plus. 24 minus 18 is 6. Is there any other thing to cancel? There's no other thing to cancel. So let us now combine the reaction. So combining the reaction, we take the things on the reactant side, put on the reactant side, take the things on the product side, put on the product side. So we have 6MnO4 minus plus 6H plus plus, okay, plus 3I minus. All right, we have taken care of the things on the reactor side. Let's go to the product side. So we have 6MnO2 minus, okay, there's no minus there, then plus 3H2O, then plus 3iO3 minus. All right, so let us check if it is balanced. Now, if you look at this, first of all, you realize that we can break everything down. Okay, we can break everything down by dividing everything by 3. That's what I was trying to explain there. If you don't want to be confused, just multiply the electrons in equation 1 by equation 2, and just like we did, then come here and see how you can break it down, simplify. So if you look at it, all of them can be divisible by 3. If we divide everything by 3, we'll have 6 divided by 3, we'll have 2MnO4. So now divide all by 3, then plus 6 divided by 3 is 2H plus I minus to give you 2MnO2 plus 3 divided by 3 H2O, then plus iO3 minus. Now let's check if it is balanced. Manganese is 2 here, manganese is 2 here. Oxygen is 2 times 4 8, while oxygen is 2 times 2 4. Okay, 4 plus, okay, let's check 2 times 2 4. Then we have 5 here plus 3 8, balance. Hydrogen is 2 here, hydrogen is 2 here, iodine is 1 here, iodine is 1 here. So this is your balanced reaction in an acidic medium. That's your balanced reaction in an acidic medium. So this is how to balance a redox reaction in acidic medium. All right. So we had to take a short break. Okay, I'm back. Okay, so basically, we are going to be looking at how to balance. All right, basically, I stated at the initial moment that there are two mediums through which we can balance redox reactions. I said the acidic medium number one, and I said the basic medium number two. When you're being given a reaction, you'll be stated in what medium to balance. I will be teaching you how to balance in basic medium. It's a very short and a very precise way. I'll be giving you a shortcut that will enable you to balance redox reactions in basic medium faster. Now look at these guys. This is what we were able to achieve after balancing this particular reaction in an acidic medium. How then can we change this to a basic medium? How do we now represent this in a basic medium without going through all different long processes. Now, this is it. When you are given a question to balance a particular reaction in a basic medium, you have to first of all balance it in an acidic medium. When you have gotten your balanced equation like what we have here, you can transform it to a basic medium. This is a very short and easy way to balance in a basic medium. You have to first of all balance it in an acidic medium, then you change what you have gotten to a basic medium. How do you do that? Now let's look at this. This is what we got after balancing in acidic medium. How can we transform it to a basic medium? It's simple. Now, we have to identify the hydrogen ion here. The reason why this is an acidic medium is because you're having hydrogen ion here, H plus. If it's a basic medium, you'll be having hydroxyl ion, which is OH minus in the reaction. Now, we're having H plus here. Now, you look at the final answer, okay, that you got after you have balanced in acidic medium. The number of hydrogen ions here, add the same equivalent number of hydroxyl ions to both sides. Very simple. We have 2H plus here. So what we have to do is to add 2OH minus to both sides of the equation. Now, the reason for this addition is so you can be able to neutralize the hydrogen ion to form water. It is the hydroxyl ion that neutralizes the hydrogen ion in this particular reaction. So look at what I'm saying here. So in basic medium, okay, comma, add OH minus to both sides of the equation based on the amount of H plus. Simple. This is the left hand side, this is the right hand side. So what do? We say 2MnO4 plus 2H plus I minus, then plus 2OH minus to give us 2MnO2 plus H2O plus IO3 minus, then plus still 2OH minus. Remember that you are supposed to add hydroxyl ion on both sides of the equation. Now, this is where we have hydrogen ion. Remember that hydroxyl ion is supposed to neutralize hydrogen ion. So what do you do at this point? Very simple. What you have to do at this point is to add these 2H plus and 2OH minus. When you add H plus and OH minus, you get water. Because if water dissociates to form hydrogen ion and hydroxyl ion. In fact, that is the property of water that makes it an amphoteric substance, which is a substance that can act as both an acid and as a base. So having this and this, so you say 2MnO4 plus 2H2O, then plus I minus to give you 2MnO2 plus H2O plus IO3 minus, then plus 2OH minus. Now, if you look at this reaction, you will not see hydrogen ion again. Rather, you're seeing hydroxyl ion. This is what makes it a reaction that has been balanced in the basic medium. This is the property of a base. Remember that a base is any substance that can produce hydroxyl ion as the only negatively charged particle in a reaction, while an acid is any substance that can produce hydrogen ion, that is H plus, as the only positively charged particle in a reaction. So let us now check if it is balanced. Remember, we had minus here, please. Let us not forget to impute whatever charge because it will affect. We had minus here. Oh. Remember, this I had have minus as well. IO3 has minus. This one doesn't have any negative charge. All right. So let us check if it is balanced. So manganese is 2 here, manganese is 2 here as well. All right. Oxygen is 2 times 4, that is 8. 8 plus 2, 10. Oxygen is 2 times 2 here, 4. 4 plus 1, 5. 5 plus 3, 8. 8 plus 2, 10. Oxygen is balanced. Hydrogen is 4 here. Hydrogen is also 2 plus 2, 4 here. All right. Iodine is 1, iodine is also 1. So as you can see, it is balanced. The next thing is to check if the charges are balanced. So let us check if the charges are balanced. All right. So we can divide them like this. You can see reactants. Okay. So reactants here, we have on this side, we have -2 plus 0, then plus -1. While products, here we have 0 plus 0, then we have plus -1, then we have plus -2. These are the charges. All right, so let us check. So for reactants, -2 plus 0 -1 is -3. For product, 0 plus 0 0, then plus minus is -1 -2 is -3. So as you can see, the charges are balanced. So this is the balanced chemical equation or balanced redox reaction in an acidic medium. All right. So I'll be giving you what you try. So kindly try this and send your answers. You can input your answers in the comment box, okay, below, or you send it directly to me on WhatsApp. Okay. So you'll be balancing this reaction. You'll be balancing this reaction in both acidic and basic medium. So this is the reaction CrO2O7 2 minus plus Fe2 plus will give us CrO3 plus plus Fe3 plus.